Over the next few days, we're going to be talking about some different features of what are called sinusoidal functions. Sinusoidal functions are wave functions. By the way, they are graphs that are shaped like the sine function. Sine and cosine are both going to fit into the sinusoidal function category. And so anyway, so if I talk about sinusoids or sinusoidal functions, probably talking about either sine or cosine. So they're these kind of wave type functions, and there are a couple of features that you need to understand to be able to answer some of the questions we're going to be dealing with. So a couple of different things. First of all, the amplitude. Some of you may have seen this with sound waves. Sound waves will follow this type of sinusoidal pattern. The amplitude is it's basically, well actually, you know what, let me talk about the midline first. The midline is basically where the x-axis is in this particular graph, okay? It's going to cut down right down through the center of the graph. Now I could shift this up and the midline would move up. I could shift it down and the midline would move down. But this thing right here is the midline. And again, the graph is going to be kind of symmetrical around the midline. It's going to kind of zigzag around that midline, okay? Now the amplitude. The amplitude is the height of the graph above or below the midline, okay? So this particular graph is going to hit a maximum value of 1, okay? So we can say that this graph has an amplitude of 1, okay? So notice the entire height from the highest point to the lowest point of the graph is 2. So you could say that the amplitude is half the difference between the highest and lowest point. But anyway, the key there is amplitude is always 1, okay? Or I'm sorry, the amplitude is always the height above the midline, okay? Amplitude is always positive, okay? We'll see some cases where you have a negative number that's used to determine the amplitude, but the amplitude itself will always be a positive value, okay? These are called periodic functions because they repeat over and over again, okay? The period of the function is basically the distance over which it takes the function to go through one cycle, okay? So let's say this was a function that passed at 0 degrees and 180 degrees and 360 degrees. You can see it starts out along the x-axis here, goes through the cycle that's above the x-axis, then it goes through the cycle below the x-axis, and then this pattern is going to start over again and continue out infinitely. Okay, so the period of this particular function that I've drawn on the board is 360 degrees. Or if you were working with radians, it would pass at 0, pi radians, and 2 pi radians. Okay, it's basically how far horizontally it takes for the function to go through one complete cycle. Okay, so that's the period. Okay, now phase shift. Basically the phase shift is just going to be how far the graph is picked up and moved left to right, forward or backward. So we're going to look at some different transformations with these graphs. So for example, if I took this same function and let's say it's crossing at the origin right now. If I took this same function and I picked that function up and said, okay, now that function is going to start at 30 degrees and it's going to continue from there. We would say that there was a phase shift 30 degrees to the right, okay? It's basically just a horizontal translation, but when we're working with these periodic functions, we're going to call it a phase shift instead. So I think that's the primary vocab that you need to be able to do these problems, but I wanted to make sure that I had that laid out carefully. So if you have any questions about that, feel free to let me know and I'll do the best I can to help.